Alright, so now we can start the lecture videos for Chapter 6. We're going to begin with 6.1, Discrete Probability Distributions. So the first thing we want to talk about is the difference between discrete and continuous, because it's kind of a big deal. Discrete is what we're going to deal with in Chapter 6, namely variables that cannot take on, I don't want to say this, variables that are counted. So if you're counting how many or the number of, that's discrete. Continuous are things that you measure. So they could take on any one of infinite possible values if you could just get a measurement tool fine enough. So for example, the time it takes for a light bulb to burn out, that is continuous. Okay? Because if you could just measure it finely enough, you could get lots and lots and lots of decimal places. That's what they do in the Olympics, right? Now the number of free throw attempts, is discrete, because you can't make 0.236 of a free throw attempt. You either make the attempt or you don't, but you can't mix it. The weight of a T-bone steak, that's continuous, right? Because again, you could measure it finer if you just had a better scale. In general, things that are measured are continuous. Things that are counted, like the number of people who have blood type A, that's discrete, right? Either you have blood type A or you don't, but you can't mix. Cool. All right, and that's a review, by the way. I mean, we covered discrete versus continuous way back in Chapter 1, believe it or not. All right, a probability distribution of a discrete random variable provides the possible values of the random variable and their corresponding probabilities. A probability distribution can be in the form of a graph, a table, or a mathematical formula. And I want to ask a further question. Okay. So here I have the actual Red Sox games for 2004 season for the Boston Red Sox. And I want to find the probability. But probability is the same as relative frequency, right? So if you picked a game at random from that season, what were the chances that it was 0 home runs? What are the chances it's 1 home run, and so on? And I'm going to make Excel do this work for me. And I've already copied it in there. Aren't I crafty? Okay, so what I need to do is two things. First of all, I need to find the sum. So equals sum of that. That way I know that there were 162 home runs hit in that season. And then I want to find the relative frequency, which we learned how to do way back in Chapter 2. But you find B2 divided by B8, right? But you give B8 dollar signs. So make it $B, $8. That way, when I autofill down the column, you can drag it or you can double click and it fills it in. That way I keep all the decimal places, and every time it's B8. B8 never changes because that was 162 home runs that season, and that's not going to change. Okay, so let me copy. I'll go over here and paste. I've actually kept way more than 3 decimal places here. If you want to round to 3 decimal places, that's not hard to do. I could just format these cells, right click, format, and choose number, and choose 3 decimal places, and say OK. Now they're 3 decimal places. Isn't that great? Here. All right, now notice these numbers satisfy these rules. Every single one of them was between 0 and 1. That's rule number 2. And rule number 1, do they add up to 1? Well, let me drag my sum formula over here. Yep, they add up to 1. So if you take the sum of C2 through C7, you get 1. Cool. All right, now what type of probability is this? That was my question. And the answer is empirical. Remember that from section 5.1? Because you got this from actual data, because the probabilities came from actual data. All right. Now what about down here? Well, I don't think we have time for that one. So let's wait and do that in the next video.